Now let's answer the question, who really pays taxes? We're going to look at two phenomena called tax shifting forward and backward. So who really pays taxes? Let's look at a market for apartments. An initial supply curve, this dark red line, and the demand curve, this blue line. At equilibrium point A, we have 900 apartments being rented at a price of $300 per apartment. Now let's institute a tax of $100 per apartment. That tax is going to shift the supply curve up $100 because the tax will increase costs associated with supplying apartments by $100. So we'll see a vertical shift up of the supply curve, and we can see if we compare point A to point C, that's a $100 shift. Now who pays that $100? Well, at the new supply curve we can see there's a new equilibrium at point B. At point B there's only 750 apartments being supplied at a price of $360 per apartment. So we can see that the price has risen from $300 to $360. That means that consumers are going to be paying $60 more. And so $60 or 60% of that $100 tax will be paid by people renting apartments or consumers. While the price is $360, how much are apartment owners actually going to receive? They get $360 in rent, but they have to pay the $100 tax, so their net receipt is $260. So they're going to get $40 less than they did with the market equilibrium without the tax. And so consumers pay $60 of the tax, producers pay $40 of the tax. That's who pays the taxes. Taxes shifted forward to consumers and backward to producers. Now, who actually pays it? And the distribution of that tax depends on the slope of the demand curve. Let's look at two examples. Here we've got an inelastic demand curve. It's relatively steeply sloped. We can see that the price at equilibrium is $10. After a tax, in this example it's a $5 tax, creates a new supply curve, the price has risen to $14. So $4 of the $5 tax is paid by consumers in the form of a higher price when we have an inelastic or steep demand curve. The same experiment can be done on a relatively elastic or flat demand curve. Here we have the same shift of a supply curve up of $5. And we can see the price has risen from $10 up to only $1 because we have an elastic demand curve. So in this instance, with the elastic demand curve, only $1 of the $5 is going to be passed forward to consumers. The rest of it will be with producers. How does this affect surpluses when we look at a market when we institute a tax? Well, let's look at this market where we have thousands of pounds of fish per day and price per pound. And we'll look at an example with a perfectly elastic supply curve. Now suppose we have an equilibrium with the initial supply curve and demand curve at point A with 60,000 pounds of fish per day at a price of $2 per pound. And under that situation, the total surplus would all be consumer surplus. All the area underneath the demand curve and above the price, or the areas A plus B plus C, would be consumer surplus. Now let's add a tax of $1 to the market. That shifts the supply curve up by $1 and gets us a new equilibrium at point B. Consumer surplus is smaller. It's now the area A only, this blue triangle, the area under demand and above the new price. The area B represents the tax revenue that results from it. It's the $1 tax times the quantity that's being produced, which is 40,000 fish per day. So this rectangle, shaded red, is the tax revenue that's generated. And then area C is the deadweight loss that's associated with this tax.